It's an honor to be here this afternoon and talk to you guys. And a little bit more about myself. I'm a planetary scientist. I was trained in physics and astrophysics, did my PhD in astrophysics, but I spent my whole career studying our solar system. My interest started off using telescopes, but really very quickly evolved. I got involved in space flight. And I got hooked on that kind of thing when I was a little boy, watching Apollo. And all I wanted to do was hurry up and grow up and be a part of that. And I've been very fortunate to be able to spend my whole career and make a living on NASA, primarily NASA robotic missions. But I've also been involved in shuttle missions and flying in space on Virgin Galactic. Hopefully later this year, I'm the first scientists that NASA selected to do experiments on a suborbital flight. And I've done a number of other things along the way, expeditions to Antarctica. And as Tony said, took a dive in a submersible down to the Titanic. And we can talk about all kinds of stuff. I've been fortunate to be involved in 29 NASA or European Space Agency missions, from suborbital to orbital to the planets. And on 14 of those, I was in charge as the principal investigator. Of all of those 29 missions, without a doubt, New Horizons, which I'm going to talk to you about today, is my favorite. When I was growing up, the very first missions to the planets were taking place, the first missions to Mars and Venus, and then further afield to Mercury and Jupiter, and then on outward. And those were the most prized missions for planetary scientists to be a part of, to be on a mission that explored a whole new planet or planet in its system of moons. And in my parents' generation, not that my parents were scientists, but in the generation of planetary scientists who were my parents' age, like Carl Sagan, that's all they wanted to do: get on the first mission to Mars, get on the first mission to Venus, because everything you discover, everything you see is new. By the time I got out of graduate school and was a working planetary scientist, it was the early 90s. And the United States had trailblazed its way across the solar system, all the way from Mercury to Neptune. And there really wasn't any other game in town in terms of a first mission to a new planet. At least we thought at that time. We didn't realize there were so many planets further out. But, Pluto was it. It was the unfinished business of planetary exploration. And I was part of a group of young scientists that started pushing to get a mission to Pluto and succeeded at that. It took, and I'm not exaggerating, 17 years to raise the money and to design and build that spacecraft. And then it took another 9.5 years to fly it to Pluto. And we weren't lollygagging either. It was the fastest spacecraft ever launched. And then since then, we've been exploring the Kuiper Belt for another 7 years. This has been a long enterprise, but the results have been spectacular. I only have time to tell you a little about that, but that's what I'm going to do. And the title here is something I'm very proud of. Our team, which consisted when we were building it of 2,500 American men and women that built the spacecraft, the ground system, the launch vehicle, and the nuclear power generator, carried out the farthest exploration of worlds in history. And nothing's coming our way to eclipse us anytime soon. This is it. I used to call the exploration of Pluto the Everest of planetary exploration. I still believe that. So let me tell you a little about New Horizons, which flew by Pluto and its 5 moons in 2015. Here on the introductory slide, in addition to that artist's concept of what it would be like to open the door to Planet 9, you can see the mission decal. And Tony, as a fan of Planet 9, you'll notice that the decal is 9-sided. You also see a model of the spacecraft, full-sized, hanging in a high bay at the Air and Space Museum in Washington. And to my liking, right in front of an American flag. That model is now downtown, not at Udvar-Hazy anymore, but at the downtown museum next to the Voyagers. About 1 in 100 spacecraft end up with models in the Smithsonian. We were very proud of the fact that they invited us. Let me jump right in. I think I can advance the slide. So this is just a cartoon view of the mission plan after we got it built. We launched it from the Earth in January of 2006, straight into interplanetary flight, same afternoon. We flew a very fast trajectory directly to Jupiter. We set the speed record for getting to Jupiter. By the way, for those who are buffs of Apollo, you know, Apollo launched 3 astronauts at a time to the moon at speeds 25,000 miles an hour, and it took 3 days to get to the moon. New Horizons launched so fast that we crossed the orbit of the moon 9 hours after launch. And unlike the previous mission to Jupiter, which took 6.5 years, we made the crossing 500 million miles in 13 months. We flew by the Jupiter system in February of 2007, not to go sightseeing, but to get a speed boost, a gravity assist, that cut our flight time to Pluto from what would have been 14 years down to 9.5. Now, turns out Jupiter is the only thing we passed along the way. And we used it for a flight test. We did a lot of science at Jupiter. And then after we passed Jupiter in February of 2007, we went off across the great expanse, the ocean of space of the middle solar system, from Jupiter's orbit 500 million miles to the sun out to Pluto's 3 billion miles from the sun. And we intercepted Pluto in July of 2015. And then we're on an escape trajectory from the solar system, headed out to the stars like the Voyagers are. And we are now in this ring of leftover material from the formation of the solar system called the Kuiper Belt, which is out at nearly absolute zero temperatures and is very well preserved. And we've been studying Kuiper Belt objects ever since we left Pluto, and hope to continue to do that for quite a while. Trying to advance the slides. Yeah, so I don't know how many of you have seen this picture before, but this is the very best picture of Pluto ever made before New Horizons. It was made, and I was the PI, the principal investigator of this project. We used the biggest telescope with the best resolution we could find, is Hubble Space Telescope. It's just that Pluto is so far away that it's just really a smudge in the distance. You can barely tell that there are surface markings, but you can't make anything out of them, because what's needed to explore a planet are images like these with real resolution, where you're up close and personal. This is a picture of the Earth made by Apollo astronauts as they were leaving for the moon in December of 1972. And with an image like this, you can do real science. And of course, we took many sophisticated instruments, not just cameras and color cameras, but mapping spectrometers and atmospheric instruments and plasma instruments and so forth on this little spacecraft called New Horizons. Here it is in cartoon form with arrows pointing to each of the 7 scientific instruments. And then in the upper right, you see an inset of the spacecraft all dressed up for launch with a couple of technicians nearby. This is down in Florida at Cape Kennedy, right? Literally days before we put it on the rocket in January of 2006. It's a very small spacecraft, intentionally so. Weighs about 1,000 pounds. That's with fuel. And it carried almost 200 pounds of fuel. It's going so far from the sun that you can't use solar power, so we have a nuclear-powered generator on board, just like the Voyagers and other spacecraft that have gone very far from the sun. That's the black hair curler looking device sticking out from the spacecraft in the image and in the artist's conception. For scale, you can see the 2 people. The diameter of the dish antenna on top is about 7 feet across. And inside that spacecraft are all the systems needed for the long flight. In fact, everything is twinned. We carry backups of everything. Backup propellant lines, backup computers, backup transmitters, backup receivers, backup solid state memories, backup gyros, backup star trackers, And the list goes on. Everything except the structure, the fuel tank, and the nuclear power generator on the spacecraft is twinned. So we have an A side and a B side. And then there's 7 scientific instruments. And although we didn't carry 2 of any of those except the one called REX, which is part of the telecommunications system, we carried 2 of those. Every one of those instruments has internal redundancy, so that if power supplies fail or microprocessors or detectors, in almost every case, inside the box, there's redundancy to protect us, because it's a very long flight, 9.5 years to Pluto. And I'm sure you've heard this before, but it's true. No repair stations along the way. This is our launch vehicle. It was until very recently, with the launch of the SLS and then Starship from SpaceX, the most powerful launch vehicle in the U.S. inventory. This is an Atlas V in its most powerful incarnation, with 7, you only see 3 here, but 7 strap-on solid rocket motors. That's as many as you can fit on the thing. Its most powerful upper stage, and a 3rd stage inside the nose cone that's unique to New Horizons. The launch vehicle is about 225 feet tall, and it's very loud when it gets up and goes. This is actually a picture of myself in front of the spacecraft inside the nose cone. I'm not in the nose cone, but the spacecraft is. The nuclear power generator is sticking out towards me. And in fact, this picture was the last picture ever taken of New Horizons, because the plutonium, which is radioactive, was put inside that black cylinder literally minutes before this picture was taken, and it was hot. And so they allowed a few of us to get your picture taken, but you can't stand in front of the radiation source very long. And then they closed the door, and that's the last anybody ever saw of this spacecraft. And after that, it was in the nose cone. This was on a Friday, January the 13th of 2006. We launched it 5 days later on Thursday the 19th. I guess it's 6 days later. 6 days later on Thursday the 19th. And I've got a video of the launch.
Got to check.
And
No Atlas.
hopefully you can even hear the announcer. I'll play this. It runs about a minute and a half.
10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. We have ignition and liftoff of NASA's New Horizons spacecraft on a decade-long voyage to visit the planet Pluto and then beyond. That's 15 seconds. We'll continue to look good as the Atlas V vehicle climbs away from Florida's East Coast. 5 solid rocket strap-on modules are burning just fine, sending the New Horizons spacecraft on its way to the very edge of our solar system.
Well, that was our launch back in January of 2006. And then we sped on this direct trajectory to Jupiter. And during that 13 months, we got the spacecraft checked out, prime and backup systems, uploaded some fancier software, got all the instruments checked out and calibrated, and then planned a Jupiter flyby, which took place in late February and early March of 2007. And then after a right on target Jupiter gravity assist, we started downloading all the data. Here's an image of Jupiter made by New Horizons, and an image of its volcanic moon Io, also made by New Horizons. You can see one of the volcanoes going off at the pole. That blue smudge up there is a apron from a very large volcano called Tabashtar. We published all the scientific results in Science later that year. And then, of course, the spacecraft speeding across the solar system, across the orbit of Saturn in 2008, Uranus in 2011, across the orbit of Neptune in 2014, and went on to intercept Pluto in 2015. And during this time, my team, which was no longer 2,500 people in flight, there's only about 50 of us. You don't need all the people that you need when you're building it, testing it. Just mission control and a science team and a couple of admins. We were planning the exploration of Pluto. And for scale, Voyager needed about 450 people to do that planning. We had more modern tools like spreadsheets and yellow sticky pads and very fast computers. So we could do it with about 1/10 as many people. But still, we were very busy during those years to make all the plans and the backup plans and to do all the navigation and to take care of the spacecraft and so forth to get us to the Pluto system. And in the summer of 2015, we started taking imagery on approach. This is one image, kind of a family portrait. If you can see my cursor, Pluto's in the lower right. And then its very largest moon, called Charon, about half Pluto's size, is up there in the upper left. And then two of the very smallest moons are in the upper left-hand corner. They're just rocks, really. They measure the size of counties, not the size of a continent like Pluto. And these are to true color. It's hard to tell the scales because different things are at different distances from you. But Pluto just turned out to be spectacular. This is a color montage of the planet, consisting of many images made by New Horizons and wrapped on a sphere to give you the appearance you would have if you were riding on a spacecraft about 1,000 kilometers above Pluto. And you're actually, the dominant feature you're seeing here is a large nitrogen ice glacier, the white thing, called Sputnik. We named it after the very first spacecraft. And many of the features on the surface of Pluto are named after pioneers of spaceflight and the exploration of the Earth and the Earth's atmosphere. You can see that Sputnik, which is a glacier, the largest glacier in the solar system, about 1 million square kilometers. For scale, it's about the surface area of Texas and Oklahoma combined. That glacier sits in an enormous basin gouged out by an impact on Pluto and is surrounded by mountain ranges that stretch much higher than the Rockies, where I live, about 15,000 feet above the plain. And they ring the whole basin. They were actually excavated and uplifted by the force of that impact to gouge the basin. The basin then filled up with this nitrogen ice over a long period of time. We studied Pluto's atmosphere. This is an actual true color image. Looking back at the atmosphere, it is blue, just like the Earth's atmosphere. It has many layers in it of hazes that stretch up about 500,000 feet into the atmosphere. That's much higher than the Earth's atmosphere. It's because Pluto's gravity is lower, so it doesn't bind its atmosphere as close to the surface. If you look at that image, and I don't know if you're seeing my cursor, but if you look just below the limb of the planet, you'll see some sort of brighter pixels with darker streaks in them vertically. Those are real. Those are ground fogs down on the surface of Pluto with the shadows from mountains on the limb, just like you'd see corpuscular rays on the Earth. Pretty dramatic. But there's all kinds of dramatic terrain across Pluto. This is an area on Pluto's surface about the size of the state of Colorado, where I live, with mountains that are just about as high as the Rockies. The red material is organic silt that has come out of the atmosphere created by ultraviolet sunlight interacting with the methane in Pluto's atmosphere. And these are organic materials, not living, but simply made of carbon molecules that are truly red in color. The mountain ranges have snow caps, and you can see them, just like here in the Rockies. In fact, I'm looking out a window and I can see bright snow caps to the west of my place. And these mountains are about the same altitude, have snow caps. They look like the Rockies do today. But the difference is the Rockies, the snow is water ice. Here it's condensed methane, natural gas on the surface. It makes a similarly bright white snow. There's another kind of mountain range on Pluto called bladed terrains, or sometimes we call it snakeskin. And these are aligned mountains that are individually several thousand feet high, and they run for hundreds of kilometers, aligned together, sort of north-south. They're made of methane as well. We don't really understand what causes this bladed terrain. It's not seen anywhere else in the solar system. They may be giant methane crystals that precipitated out of the atmosphere and grew over billions of years, or they might be the remnants, the stronger remnants of what used to be filled in mountains that simply had wind or some other type of maybe thermal erosion that excavated weaker materials to create thousands of valleys. This is one of my favorite images on the surface of Pluto, simply because it shows you terrain that's very old. And we know it's old because we count the craters on it. And, the surface of Pluto, like every surface in the solar system, records impacts that make holes in the ground called craters. And the older the surface is, the more craters you see on it. And because we know the rate at which it's cratered, we can actually take the number of craters as a function of size and with a computer model estimate the age. Here we're looking at a surface that's 4 billion years old. So it's as old as the planet. And in this image, taken on the glacier, not very far away, has no craters whatsoever. Very young surface. It's evidence that the glacier is active today, just like a glacier in Greenland, for example. It's not made of the same stuff. Instead of being made of water snow, this is made of nitrogen snow. It's prevalent at these very low temperatures near absolute zero in the Plutonian environment. But you can't find a single crater here. And we can age date this surface as no older than maybe the age of the hominid species, our hominid lineage of our species on the Earth, 10 million years old or less. So what we found is the glacier is renewing itself all the time. And how this feature, the size of Texas and Oklahoma combined, can be active on this little planet the size of continental United States 4 billion years after the planet formed is a complete mystery. But nonetheless, it's there. So we have to figure it out. There's other kinds of activity on Pluto. This is a topographic map showing high mountains to the right, to the east, as high as 5 or 6 kilometers, so 18,000 feet at the peaks. And then down on the glacial valley, which is the purple terrain to the west, and where the black diamond is, you can see a mountain chute where there was a avalanche that spilled new material out into that pool, the perimeter of which is shown with those red arrows, over about the size of an area a little bigger than Greater Denver, where I live. And this has no craters on it either. So this is something that happened in the recent geologic past. And we see, if that wasn't enough, Pluto has volcanoes, ice volcanoes on the surface, the size of Mauna Loa in Hawaii. This is one of them. It's about 14,000 feet high, 150 kilometers across. And again, no craters, again, telling us that this was constructed in the relatively recent past. We even see this strange beast, which is a frozen lake. And we know that's what it is. First, we can fingerprint its composition from the spectrometers, and we know that it's nitrogen. Second, we have stereoscopic imaging that allows us to reconstruct the topography. And so we can see that this is a perfectly flat surface, just like a liquid would create in a hanging valley, just like lakes in the high country here in Colorado. This is about the lake, which I'm circling with my cursor here, is about 20 miles or 30 kilometers long. And the interesting thing about that is that Pluto's atmosphere is too thin doesn't have enough pressure to allow liquids to flow or stand on the surface. So if this really is a mountain lake, as it appears, it indicates that Pluto's atmosphere long ago was much higher pressure even than Mars, and close to the pressure in the Earth's atmosphere. This is kind of forensic evidence, like a CSI episode of a very different Pluto long ago. And this is a candid shot taken in our science room on the morning of the flyby when the first high resolution image came down. I like it because nobody posed for this. It's really a bunch of nerd scientists on seeing what they've been chasing for 9 years for the first time. And it was pretty emotional. We didn't know if it would work. We only had one spacecraft and one shot at it, speeding by at 36,000 miles an hour, and it all worked itself out. After we left Pluto, we went on to explore the Kuiper Belt, this ancient region of the solar system with all these fossil planetesimals. And if you don't know that term, a planetesimal it literally means little planet, but they are the building blocks of planets, the things out of which objects like Pluto were made. And the one that we went after first, which is called Arrokoth, was one we discovered while the spacecraft was in flight. And we discovered it with a Hubble Space Telescope. It's right along our trajectory. We barely had to maneuver the spacecraft off the line that took us from Earth to Pluto. But it was much further out than Pluto, where the sunlight is really faint, 2,000 times fainter than at high noon on the Earth. And so we had to navigate to and chase down this little chunk, more or less in the darkness of the outer solar system. And again, it was kind of a one shot. This is actually a little video where this is the surface of Pluto. And it's going to, when I push the button in a sec, it's going to zoom up for you on Pluto. And then it's going to put a little scale model of Arrokoth down there just for scale. So you see how tiny Arrokoth is. Arrokoth's about the size of maybe a small county in Iowa, for example. Formed 4.5 billion years ago. You'll see how it compares even to mountain blocks on Pluto. It's similar size. Here we go. And this only lasts about 5 seconds, so don't blink. Ready, set, here we go. I'm going to zoom up. We're going to put Arrokoth there for scale. And that's what we had to hunt down in the darkness of the outer solar system. And we did. And we flew by it on January 1st, 2019, 4 years ago. And it all worked out just fine. This is 3 a.m. on January 1st, 2019, when the first image of Arrokoth came to the ground. And you can see it's perfectly centered in the frame. Here we are zipping by at 36,000 miles an hour with one shot to get that image just right. And we did. And the end result is it's a very strange beast. It's something in planetary science we call a contact binary. Binary meaning it's really two objects, two lobes, as we call them. And you can see they're in contact at the joint, the bright circular joint between the larger lobe to the left and the smaller lobe to the right. And I think even as non-scientists, those of you who aren't, can tell just looking at this that there's no signs of violence in the way these two objects came together, that they came together very gently, which tells us something very important about the natal environment where they were formed. For decades, there were two competing theories of how planetesimals form. One was through high-speed collisions, one was through gentle collisions. This sort of cinches the case for gentle collisions and eliminates the high-speed collision theory. There were mathematical models and computer simulations going from the late 60s into the 2010s. And we kind of settled the matter by seeing this object, because this is the most pristine, most well-preserved object ever explored by any spacecraft. It's out so far that there's no heating, there's very little radiation, there are very few collisions. It's just very well preserved, being kept at nearly absolute zero all this time. And this is in true color, by the way. Here's another depiction of the object. This is in black and white because our black and white camera has a longer telescope, so higher resolution. But you get a feeling for both the double lobe nature of the object, the amount of surface detail that we can see, but also you can see from this set of images taken from different angles that the object really isn't spherical at all. These are more like two flat stones that you would skip on a lake, except, of course, they're 10 kilometers across in the smaller one, and the bigger one's 20 kilometers across. But you can see how flattened it is, which is another clue to how its origin happened. This is what we think happened in it. There was a gentle collapse from a natal cloud of material in a very small local pocket of the solar system that accreted into these two bodies that got into orbit around one another. They mutually captured in terms of their gravity. And if you look back at this, you should note that the two lobes are not stuck together randomly. The more roundish one on the right isn't just sitting on top of the other one. It's actually got its principal axes aligned. And so we think that the two objects orbited one another, and their very small amounts of gravity caused the object's principal axes to align and merge together over time, very gently, at something like walking speed. And we have some pretty good constraints from the geology that show that it can't be more than miles per hour, or we would see evidence of fractures and other features that we do not see. And we believe that since we pulled this one out of a grab bag randomly, that this is telling us in general about the planetesimals of the outer solar system, that they form through this gentle accretion mechanism in these local natal collapse clouds. And this occurred billions and billions of times, made billions and billions of planetesimals, which then ran into one another over time and merged to make planets like Pluto. Now, ever since this flyby in 2019, we've been looking for a new flyby target, and all the while continuing to study other Kuiper Belt objects as we pass them in the distance with our telescopes. We are now in our second extended mission for New Horizons. We hope to fly New Horizons another 25 to 30 years. We have the power and the fuel to do it. We have the communications range to do it. The spacecraft is very healthy, so are all the scientific sensors. We're not using any backup systems. Nothing's failed. The spacecraft's more or less as good as it was the day we launched it. We are currently in a fight with NASA because they would like to end the planetary exploration of the Kuiper Belt 5 years before we leave the Kuiper Belt and repurpose the spacecraft to study the sun's environment, which we think is a mistake. And I don't know how that's going to turn out. I hope that we get to continue exploring the Kuiper Belt till we leave it, which is probably in 2028, maybe 2027. And so we'll just have to see how those politics work out. If you want to know more about this story, David Grinspoon and I wrote a book. It was published in 2018, after the exploration of Pluto and before the exploration of Arrokoth. It tells the whole inside story of how we came to get this funded, how we designed it and built it and flew it across the solar system, and a lot more detail about what we found. And you can see from the back cover some of the people like Bill Nye and Jim Lovell and Brian May and Mark Kelly that read it and liked it, David Blaine, the illusionist. So with that, I think I'm done with the presentation.